This is the lesson 9.2, check for understanding. You can see the quick notes on the top that we did in class. Um, I think in class I added in top of these, I added independent. These are nothing new. This over here on the right side, this is what's new. We are getting a z-score for our p-hat, for our sample, for our statistic. And from that, this is called the test statistic. Then we get a p-value, and then we decide if we're going to reject the null hypothesis or not. All right, the question here, you can read it to yourself and then continue the video. But they're asking college students um, um, they watched audition tapes of 12 different singers. They watched them in random order. Um, they would expect approximately, if they watched 12 random singers, wouldn't it be logical that about 1/12 of them would prefer the last singer that they saw? Or is there something more to it? Like the last person you saw is fresh in your memory, so you're more likely to pick them. So assuming order doesn't matter, P should be 1/12. But in the study, 59 of the 600 students preferred the last singer that they viewed. We want to perform a test at the alpha of 0.05. The null is that the probability would be 1/12. If you take your calculator and divide that's 0.083 repeating, okay? The alternative that they're giving us is that the probability is actually greater. Like I was saying, you prefer the last singer. So this probability of picking that last singer would be larger than 1/12. P is the proportion of college kids who prefer the last singer that they see. All right, why does the data give some evidence that college kids prefer the last singer? Well, this isn't saying do the whole test. This is just saying like why, looking at this at the statistic we have, is that at least a head start to suggest that this would be greater than? And it is. So if you take your sample, it was 59 out of 600, okay, and you divide that, you get about 0.0983. So it is larger, right? It is greater than 0.0833. So that is what they mean by some evidence. Okay, checking the conditions. This should be like becoming very routine by now. Was it random? It said that it was a random sample of 600 kids, of college kids, so we're good. They looked at the videos in a random order, so we're good, very random. Large counts. One thing to point out here, this is you have to have 10 successes and 10 failures. So we had 600 college kids, right? Did we have at least uh, 10 that picked the last singer and 10 that did not pick the last singer? But notice, what P are we using? We are not using P hat. We're not using this, okay? We are using the P, the parameter that we think is true. In other words, this 50 is what we expect based on the null hypothesis. The null hypothesis is 0.083, okay? So when you do 600, your sample size, that's n, times the null probability, you get 50. So it's not actually 59. That would be a common mistake. A lot of kids say, oh, look, there's my successes, but it's not. It has to be based on the null hypothesis. Likewise, then this here over here would be 1 minus 0.0833. So 50 successes and 550 failures, so to speak. But they're both greater than 10. So we're good. Independent, you could just state that each college student's preference is independent. Um, Preference is independent. You could also use the 10% rule or the 10n rule. Take 10 times n, that's 10 times 600. That is 6,000. Is that less than the population? Well, that begs the question, what's the population? The population is college students, okay? There are far more than 6,000 college kids. There's there's like 50,000 at the U of M alone. So those are our three conditions. This getting the test statistic essentially is get the z-score, folks. So we know our p-hat. That is 0.0983 goes here. So what would we have? We'd have 0.0983 minus the null, which is 0.0833. That's We're operating under the null hypothesis. We're assuming P naught is 1/12th, right? 1/12th. And then notice in this denominator, we are using the 0.0833, okay? Because we're operating under the assumption, when we do this entire test, we're operating under the assumption that the null hypothesis is true. So this would be 0.0833, 1 minus 0.0833 over n is 600, okay? How would I do this on a calculator? Like so. I would do the numerator first. So essentially I know that this statistic is about 1.5% above what I expected. Then I would do the denominator in one line. Like that. And so I've got 0.01128 and so forth. Then I'm going to type in 0.015 divided by, grab that answer, shebang. So I'm getting 1.33. Okay, this is my z-score. Okay. Now I need to use table A to get the p-value for that. So let's look up a z-score of 1.33 in the College Board packet. 1.33. Let's see here. 1.33. So we're here. So you might think, wow, that's 0.90, but remember that this is the shaded is over here, 0.9082. But what I want is I want to have a result like this or greater. I want this side. So this is 1 minus 0.9082. Okay. So beware of that. Okay. Which is what we have right here, 1 minus 0.9082, which is about 9%. Okay. Now you can use technology to do this. Okay. Um, oh, interesting. This is not where I was. Sorry. I gotta go to my notes. Boop. So yeah, we can also use technology on the calculator to do this. Again, I always encourage you to use this, especially multiple choice on an FRQ. Do the test button. The test button, you guys, will give you the statistic and it will give you the P, and there you go. That's all you need. And you enter your alpha. Okay, we're doing alpha of 0.05. So stat tests, we are doing a one sample Z test. Sorry, we're doing a one proportion Z test because these are proportions, right? Percentages of proportions. So that is number 5. If you see it on there, one proportion Z test. Now, when you're on this screen, you enter the null probability, which was 1/12, and you can see it automatically corrected it and adjusted it to the decimal form. X is the number of the students that chose the last audition. Whoops, I didn't mean to do that. And then, so 59, and then N is the number of in the sample. So as soon as I hit enter right there, you can see it has my z-score of 1.33. It has my p of 0.918, which we have matching up right here. Okay, so you can clearly show your work and do it all by hand, but then always check using the button on the calculator. Okay, finally interpret this. Our p-value, where did it end up? Our p-value is here on my handy dandy drawing, right? That's like up here. It is above alpha. Remember, if you're above alpha, you're here. You are failing to reject the null hypothesis. So we are not going to reject, okay? Because the p-value is greater than alpha, we fail to reject. Do not say, by the way, do not ever say we accept the null. That is a big no-no. We just, at this point, don't have enough data to reject it. And then one more closure sentence, right? We do not have convincing evidence that the true proportion of college kids who prefer the last singer they see is greater than 1/12. In other words, we do not have evidence that there's an advantage to performing last. All right. Thanks, everybody.